How's it going, guys? Today in this video, we're going to be going over Module 8.1, Day 1. In your notes, the very first thing you should see is a warm-up. So let's go ahead and actually try to do it. If you haven't tried it already, I'll let you pause it and go through these questions and try to think it through and see what you can get. All right? So hopefully you paused it. Hopefully you tried it. Let's go ahead and go over the warm-up. So what are the zeros of the polynomial? Remember, the zeros of a polynomial is what turns the whole polynomial into 0. Or in other words, it's your x-intercepts, your solutions, your roots. And in this problem, our zeros will be -2, since that turns x plus 2 into a 0. 1, it turns the next factor into a 0. And -3, it turns the last factor into a 0. So those are our zeros of the polynomial. Next, we're asked to write the polynomial in standard form. If you did it, you should have gotten x cubed plus 4x squared plus x minus 6. We just had a whole test about this in Module 7. You should be comfortable multiplying factors out, multiplying polynomials and binomials. And lastly, we're asked how are the zeros related to the standard form? And for a little hint, we told you guys to compare the zeros with the constant term in the standard form. And in this case, it's that the zeros are factors of the constant. So zeros are factors of -6 or your constant. Same thing. -6 here is your constant. So let's go ahead and actually start with the notes. So yes, you remember the zero product property rule. That applies to almost everything we've done this semester so far. And it's really, what it really says is that if you're multiplying two terms together, like for instance, A and B, and it equals 0, then A has to be 0, or B has to be 0, or in our cases, A and B has to equal 0. For example, if you have x plus 4 times x minus 2, and that equals 0, then x plus 4 has to equal 0, or x minus 2 has to equal 0, or both. And in this case, we get our zeros, x equals -4 and x equals 2. And I think I've said in a previous video, but this property is the reason why we always set quadratics equal to 0, and why we always set polynomials into 0 as well when we're factoring and when we're solving them out. It's because of this property. So for number 1, we have 2x plus 3 times 4x minus 5 times 6x minus 1. We're going to identify the zeros. So what we're going to do is set each factor equal to 0, and we're going to solve for x. Equals -3, and x equals -3/2. We're going to do some simple math really quickly. 4x minus 5 equals 0. 4x equals 5, x equals 5 all over 4. And lastly, 6x minus 1, set that to 0. And when you do, you get x equals 1/6. So following the zero product property rule, we just set each factor equal to 0, solve for x, and we get our zeros or our solutions, roots, x-intercepts, whatever you want to call it. They're all the same thing. You get them to be -3/2, 5/4, and 1/6. So next, we're told to multiply the factors to write on standard form. So we're going to go over this relatively quickly, since we should already be comfortable with this. We have 2x plus 3 multiplied with 4x minus 5 and 6x minus 1. We're going to multiply the first two binomials together. And when we do, this is what we get. All multiplied with 6x minus 1. We'll add like terms. And we'll multiply our new polynomial with our last factor of 6x minus 1. And when we do, we should get something like this. -15 times 6x is -90x plus 15. All right, so we have this. We're going to add like terms. 48x cubed plus 4x squared minus 92x plus 15. I know I went through that relatively quickly, but the point of this video isn't to teach you guys how to multiply binomials and polynomials. It's meant to introduce 8.1. So if you have a little trouble with that, we have previous homework problems, we have previous videos. You can go back and do some extra practice with multiplying polynomials and binomials, all right? Because you will need to know how to do that for this whole module, all right? So lastly, we're asked how are the zeros related to the standard form and how they're related. And we're going to touch on this much more in the next video. In 8.1 day 2, it's that zeros, all our zeros of a polynomial will always equal plus or minus any of our factors of the constant all over, can't get those lines to connect. All right, factors of the constant all over factors of the leading coefficient. That is the relationship between zeros and the standard form. Hopefully I spelled that right. Yeah, hopefully that's spelled right. Anyway, our zeros will always be plus or minus factors of the constant divided by factors of the leading coefficients. So if we go back to number 1A, part A, we can compare our zeros with our standard form. So according to C, our zeros should always be in the form factors of the constant divided by factors of the leading coefficient. So for x equals -3/2, 3 should be a factor of our constant term in our standard form. Our constant term in our standard form is 15. 3 is a factor of 15. And at the same time, the denominator of our 0, or 2, should be a factor of our leading coefficient, which is 48, which it is. So 3 is a factor of 15, 2 is a factor of 48. That holds true. For x, it equals 5/4. 5 is a factor of 15, which is our constant, and 4 is a factor of 48, which is our leading coefficient. So that holds true as well. And lastly, we have x equals 1/6. 1 is a factor of 15, which is our constant, and 6 is a factor of 48, which is our leading coefficient. All right, so you might not see much of a point to know this, but like I said, in the next video, on 8.1 day 2, you will see why we need to know this, why we're going to use it, and this will be a very important property to know for the rest of this module. All right, so for now, just understand that for all our zeros, it will always be, whenever we find them out, it will always be in the form factors of a constant divided by factors of the leading coefficient. All right, so a lot of this stuff we've actually went through many times before. So what I want you guys to do now is pause the video, try to do number 2, and I'll post the answers in a little bit once you've had a chance to do it. All right. Okay, so this is number 2. For number 2, your factors, or your zeros, sorry, should be -4/3, 4/2, or just +2, and -2 and -1/4. So those are what your zeros should be, and you get them by setting your factors of 3x plus 4, 2x minus 4, x plus 2, and 4x plus 1. Each individual factors, set it equal to 0 and solve for x. That's how you get your zeros. Multiply the factors to write in standard form. You should have gotten 24x to the 4th plus 38x cubed minus 88x squared minus 152x minus 32. I know it was 4 different factors to multiply out. These are some pretty big numbers, some pretty ugly numbers to multiply out. And I think that was probably the hardest part of number 2. All right. And finally, for C, how are the zeros related to the standard form? We talked about that in the previous slide. Is that all our zeros are always going to be factors of the constant divided by factors of the leading coefficient. So we go back to our zeros here. Our first zero of -4/3. 4 is a factor of our constant of -32. So that holds. 3 is a factor of 24. That holds as well. For x equals 4/2, or just 2, we're going to stick with 4/2 since that's what we exactly solved for when we solved our factor for x. 4 is a factor of 32. 2 is a factor of 24. That holds. X equals -2. Negative 2 is the same thing as negative 2 over 1. So let's actually just write that out. That is the same thing as negative 2 over 1. And negative 2 is a factor of 32. So that holds. And lastly, negative 1 over 4. 1 is a factor of 32. 1 is a factor of everything. And negative 4 is a factor of 24. So that holds as well. Okay? So that's how you use, that's not really how you use C, but that's how you can see that C is actually true, and every real rational zero of any polynomial will always follow this this property of factors of the constant over factors of the leading coefficient. So for number 3, I want you guys to do the same thing. Pause the video, and I'll post up the answers in a bit. Okay, and this is what you should have gotten for number 3. X equals negative 3 over 6, or 1/2. X equals negative 5 over 2, and x equals 5 over 8. And when you write this all in standard form, I know this was pretty ugly to do too, but you should have gotten 96x cubed plus 228x squared minus 60x minus 75. And like the previous 2 slides for C, how our zeros relate to the standard form, I don't have it written down here, but our zeros will always equal plus or minus factors of the constant as our numerator divided by factors of the leading coefficient, which is our denominator. And we can see with our zeros here, that still holds true. Okay? So I think the hardest part of this day right here is really multiplying some pretty ugly binomials and polynomials. But other than that, guys, a lot of this is relatively new stuff. Or sorry, relatively, well, I shouldn't say relatively. It's actually stuff we've already known and we've talked about throughout the semester. The biggest thing here is really going to be the C that we have here, that our zeros are going to be plus or minus factors of the constant divided by factors of the leading coefficient. And we'll see more how we use that and why it's actually useful for us in the next video.